on them. I just want to do a really quick recap because this distinction is going to be important. We're going to be doing a little bit more of a hands-on class today. We'll be doing some paper stuff, but just a quick recap from yesterday. So what we did was we learned about probability, which we know is the chance of happening, right? Specifically, we learned about experimental probability. It's going to be really important to understand what that word is. It's based on an experiment, right? It's something that has happened. The thing we did yesterday was we sorted out a crap ton of Smarties. Where's my? So we went through a bunch of Smarties, we organized it, and we used that information to predict the chance of future Smarties. Technically speaking, we should have a pretty even distribution of Smarties, right? There should have been the same number of pink and yellow and green and blue, but there wasn't. So when we look at something experimental based on real data, stuff that happened, it doesn't always line up with what we predict should happen. So like if I was to flip this coin, I have 2 coins here, right? If I'm to flip these, what do you think the outcome is going to be? Well, 50-50 to flip one. Now I have 2 coins. Doesn't that mean that one of these should be heads and the other one should be tails?
No. I should say one word.
Okay, so I like where our heads are going there. Technically speaking, you know, if I'm thinking about it, oh, it should be one heads, one tails, but that doesn't. Well, we'll get there, but it doesn't always end up like that, right? Sometimes you do that. Maybe you get 2 times, like maybe you get both sides are tails, maybe both sides are heads. It doesn't always work out where, again, 50-50 chance, I should get 1 head, 1 tails, if I flip it twice, but that doesn't always work. So theoretically, I should get 1 of each. In terms of like actual stuff that happens in the real world, not quite. Shouldn't always happen. So like, let's say for example, so you can stop shuffling your cards now. So everyone here has a deck of cards that they've been shuffling the whole time. Hopefully it's nice and shuffled. Theoretically speaking, what should happen is I want you to take the first 4 cards and just lay them down. Just the first 4 cards. You don't need to like hide it from yourself. Just flip the first 4 cards.
Wow, there's no odds of that.
What, ace of spades? Or oh
Wait, do we
yeah, just flip 4 cards. Yeah. Oh, you can flip them over. Yeah, you can flip them over.
Okay.
You don't need to hide them.
No.
So theoretically speaking, we should have we should have a spade. You should have 1 in each suit there. Does anyone not have that? Does everyone not have 1 of each suit? You have at least one that's at least 1 other common suit.
Yes.
Yeah.
Missing a club.
I don't have a heart.
Yeah. So you're missing the suit. Yeah. So what just happened is in theory, you flip 4 cards, you should get 1 of each suit, right? Like that's kind of how it works. But in the experiment that happened here is you didn't quite get that. So when we predict something's going to happen, it doesn't always work out that way, right? Like, does anyone here play poker? I'm a huge poker fan. I love poker. I'm obviously a big math guy. I do a bunch of math when I'm playing poker. I'm trying to predict, like if you ever have like
You're trying to
I'm kind of trying to count cards. Yeah, like there's strategy involved, right? And so like what I try and do is like, has anyone ever had it where like maybe you have like a 3 and 4 in your hand and there's a 5 and 6 on the table? Oh, I just need a 2, or I just need a 7. I have a straight. I'll win if I get it straight. Has anyone ever like done that and then like kept calling? Every time they flip the 4th card, they flip the 5th card. All of a sudden you don't have a straight there.
You lose your money.
And you lose your money. You can calculate the odds of that. Or has anyone ever been like I have way better cards than you? Like, has anyone ever had like I have like 2 kings? They have like nothing. And then they just get like the best card at the very end in their favor, right? You can calculate odds on that. You should have won that, but you got very unlucky. There's a small combination of cards that could have been flipped on that table to make you lose. So you're doing math when you think about it. There's lots of strategy involved, and it's basically just some basic predictions, right? Like that's what you're trying to do. So we're going to be playing a couple different games today. One of it's going to be involve cards. One of it's going to involve dice. And at some point, you're going to actually be making your own game. Literally in the curriculum, you guys get to analyze, figure out ways to win games. So we're gonna be putting some like pen and paper away really quickly to be able to do that. And so what we're gonna do is we're going to start out with blackjack.
Nice.
Noise.
That game is low.
We're gonna start off with blackjack. We're gonna play that for I think like 10 or 15 minutes, and then whoever has the most money wins the prize. I did remember. I forgot.
This gets better and better. Yeah. Where, and I take all your.
I'm gonna be in your face. You steal.
Oh.